Hello, I'm So Shi-hyun, the presenter of Team 6. We are going to use this bonus week to make up for what we didn't get right before. In the first week's presentation, we investigated about skydeck, one of the construction methods used when building. We studied the skydeck's definition, main components, advantages, and applications. However, the presentation focused only on what skydeck is, so we got feedback from the professor that we set the wrong direction. So we are going to use this bonus week to find out why the structural engineers had to use construction methods related to skydeck and how they were applied in connection with the absolute world towers. So we changed the content to why the skydeck had to use and construction method related to skydeck and how it is applied to the absolute world towers. Let's start this week's presentation. Typical buildings have fixed columns and cores, and rectangular slabs are stacked up one layer without rotating. Usually when constructing slabs in these buildings, flying table techniques are often used. The flying table technique is to move slab molds with a crane. However, the absolute world tower has fixed columns and cores, but it has an amorphous slab rotating structure. Engineers designed elliptical slabs so that all floors have different angles to create the building that looks flexible on the outside. As the layer goes up, the angle rotates, and the size of the angle is different. Because every floor has a different angle, engineers had to set the exact angle for each floor to achieve structural stability before building. If this angle is slightly different during construction, there will be structural problems. The flying table technique, a common slab construction method, was not suitable for the absolute world tower, which required a stable and accurate angle. Also, because slabs have different angle on all floors, there were parts that could not move the machine or support the mold during construction. That's why structural engineers needed guide rails so that they could move it at different angles, supporting the load on the machine or the mold. How did structural engineers solve these problems? The answer was these three methods. These are the three construction methods that we studied this week. Let's take a look at each of them. First, the skydeck, a slab construction method. Skydeck manufacturers coated panels in advance. They assemble panels to fit the slab shape directly in the field. And pour the concrete on them. After hardening concrete, they disassemble panels and take them to the next floor to repeat the same task. The absolute world tower has an elliptical shape, So the panels looks like this. Assemble most of them with standardized rectangular panels and fill the rest with specially made panels to match the shape. The core and column are fixed, but the slab has an amorphous shape and rotates that is difficult to construct, so it causes problems that take a long time to construct. However, by using Skydeck, they can shorten the construct period because it is easy to assemble and dismantle it with standardized panels. Secondly, RCS foam construction method for the wall construction method. Normal fly tables use cranes, so it's not easy to adjust clear angles. Therefore, the absolute world towers use the RCS foam, which doesn't require crane. It is operated by the interlocking climbing rail and shoe. Let's figure out the constructing process of the RCS foam. The key point of the RCS foam is the climbing rail. Climbing rail is attached on the foam and it helps the RCS foam to climb up to the next floor. The rails adjust the length of the struts themselves so that the foam can rise one floor up. After one part climbs up the floor, rail is detached from the part and attached to the next foam. Using this method, the entire layer of foam is moved in such a way that the overall RCS foam is raised. And the most important reason why RCS foam is used is that it can be stacked exactly at the right angle. Due to these advantages, RCS foam is widely used in high-rise buildings characterized by helical structures and curves. For example, the Evolution Tower in Moscow, Russia also used RCS foam. Therefore, the absolute world towers with different angle of slab rotating on each layer were also able to implement the correct angle using RCS foam. Finally, EFCO, Climbing Elevator Formwork System, a construction method to make a core. Since the walls and slabs were completed with Skydeck and RCS foam, core parts also needed to be stacked quickly at the speed of construction. In case of the absolute world towers, the slab rotates, but the core rises steadily without rotating. Then let's take a look at the construction process of EFCO applied to this building. It starts on the ground with the plate girder panels lying face side down, and then turn the first side of the plate girder column from over and bolt the second side to the first side. Next, erect the column forms and fix it to the ground. Finally, carefully pour concrete in the foam. With these three techniques, the special shape of the absolute world tower could be implemented accurately and quickly. These are references of this presentation. Thank you for watching.